Hi team. Hi team. Thanks for showing up for your learning. Quick Bedmas lesson. You're working with trigonometric functions, particularly when we need to solve a situation like when does this function equal 1/2? Okay, so if I have this situation, what I'm trying to solve looks like this. So I'll show you how we do the Bedmas. So in this case, there's not much that I can do inside the brackets here. What I'm going to have is I'm first going to go ahead and substitute that in 1/2 for h of x. That's the value of the function. It's a y value, so it goes on. It replaces the function equals sine of this. I could expand this, so I'm gonna use the distributive property to expand and simplify. So this is 6x plus 60. That's in brackets because I'm taking the sine of this number. But I've gotten as far as I can with my inverse operations. Well, no, sorry, with my algebraic simplification before using sine inverse here, because there's no a to evaluate, there's no c and things like that. So what I'm going to do is take the inverse sine of both sides, and algebraically that looks like this. Sine inverse of 1/2 is equal to 6x plus 60. Okay, now this is just a number. And the number that it is it saying what value of sine, like what does 6x plus 60 have to be for the sine of that to equal 1/2? And to answer that, we can go to our unit circle here. So here's the unit circle, and this value here, 30 degrees, has a sine of 1/2. Okay, so that's 1/2 high. This is 1, and this is root 3 over 2. So the sine is opposite over hypotenuse is 1/2. Okay, it's also over here at 150 degrees. Okay, so basically we have two things to solve. This gives us two solutions to the equation, and I'll show you where those show up graphically. So let me go ahead and we'll kick on some Desmos here. You'll notice that, it doesn't show that, and the reason is don't use square brackets in Desmos. Use round brackets only. Most doesn't like square brackets. I don't know. There we go. There it is. So we want to know when does this equal 1/2? Y equals 1/2. So it's here. Yeah. Okay. So anyway, here's one solution, and here's another solution. Okay. If I remove these, we were talking about this function. Actually, sorry. So here's a solution 30, and then here's another solution 150. Okay. We're going to transform this in just a second. But those are the solutions given by the unit circle for sine x. So what we do then is we know that this creates two situations. And I like to do them next to one another in two different colors. Here's one of them. This is 30 equals 6x plus 60. And then the other one is going to be over here, 150 equals 6x plus 60. Okay, and we solve both of these equations. So this one here, subtract 60 from both sides. This will give us negative 30, and then we have negative 30 equals 6x. Divide both sides by 6 to get negative 5 equals x. There's one solution. Why'd I use purple over there? And then over here, solving in blue for some reason, we're going to subtract 60 from both sides again, so that we get 90 is equal to 6x. And we divide both of those sides by 6 to get... I know that that's a blue pen. Why are you telling me that's a blue pen? That's very annoying. Okay, 15 is equal to x. Okay, there's our two solutions. Let's go again, take a look graphically why we're getting those. So now I'm going to put in these transformations here. So we had 6 multiplied by x minus 10. Okay, bracket. So here we go. Here's the 15. We found that one. And we also found, did I write this wrong? 6x plus 10. So we found this one here, 30 degrees. 6x plus 60. And then, yeah, so we should have negative 5. It helps if you get the signs right, Mr. Jennings. Okay, I'm embarrassed to tell you how long it took me to find that. Okay, so here we go. So now we're getting the solution of -5 and 15. All right, and then you just add the period to, say, this one. Here, the period 360 over 6 gives us 60. So if we add 60 to this -5, we'll get this 55 solution over there. And then if we add 60 to that, we get 75 over here. Oh, isn't it nice when things work out? Okay, now let's keep going. What if we have a more complex example, Mr. Jennings? Like, for example, one with an A and a C, as well as a K and a D. How do we do the Bedmas now? Okay, well, here we have J of X equals this, and we want to know when does it equal to. All right, so let's take a look at that. I'm choosing easy values of sine, by the way, but you can still do this with tricky values of sine. You just solve the equations like this. So first thing to do is to substitute that in. So 2 equals 3 multiplied by sine of 9 multiplied by x minus 20. Let's get the signs right when we write it in Desmos this time. Save us a heart attack. Plus 5. Okay, and then go ahead and subtract the c from both sides. All right, and that's going to give you -3 over here is equal to 3 sine 9 times x minus 20. Okay, and now divide both sides by 3 to give you -1 equals sine of, and we could multiply this in as well. Like that, sure. Sine of 9x minus 180. Okay, all right. So now we do this step. We take the inverse sine of both sides. Let me just scroll down here. So there I say the sine inverse of -1 is equal to 9x minus 180. Okay, and then I go hunting on the unit circle or my brain for a time when sine equals -1. It's down here. This is here you go around and around and around the circle where it stops right there. That's sine -1. Okay, 270 degrees. And you can check that on your calculator as well. So I know that, and that's the one and the only solution. That one is unique. Why? It's the bottom. It's the bottom of these. Okay, this is a different function, but it's the bottom. Okay, and so that happens only once per cycle. All right, so here I know that this is 270. Unique solution. No need to do this twice like I did over there. It's equal to 9x minus 180. All right, add 180 to both sides. All right, and that will give us 270 plus 180 gives us 450. Isn't that nice that it divides nicely by 9? Equals 9x. Now divide both sides by 9, and that will give you 50. 50 equals x. All right, and then we could add the period to create an infinite list of solutions. More on that later. All right, so up here we have j of x equals this, so let's put that into Desmos. So here's this fancy function, and we want to know when does y equal to. Okay. So we found this one here, 10. This one here, 50. Is that what we were looking for? Yeah, so we found 10, 50, and 90. Well, we found this one, 50. Okay, let's take a look at our method. See, we got all the way down here. We got 50 equals x, and that's the one of the possible solutions. But we know that the period here, 9. The k of 9 gives us 360 divided by 9 is 40. So that's why these are all separated by an interval 40. And we only found one solution for that value sine because, again, this is a minimum. So if we moved this up and we said, when does it equal 3? Well, we would have had two possible solutions, one there and one there, every time it went through one cycle. Here it has one solution per cycle. From there to there, that's a cycle. From there to there, that's a cycle. So one per cycle. And that's how you do the Bedmas. for solving trigonometric functions. Thanks very much for showing up for your learning, everyone. Any questions, hit me up in the chat or by email.